In continuation to the previous lectures about random variable, probability distribution, joint probability distributions, we are moving towards expected value. What is an expected value? When we are dealing with the probabilities, expected value is nothing but a weighted average. And weighted average, in case of probabilities for a random variable having a particular sample space, will be nothing but the average giving weightage of probability of occurrence for every occurrence of the random variable in the sample space. So this is nothing but a simple formula which will give us a value based on the weightages. And weightages here is a synonym for the probability of occurrence. This is what we call mathematical expectancy. What you expect, what is an average outcome with respect to the probability of occurrence. So now first term in this expected values is expected mean and the other term is expected variance. Mean defines the average occurrence and variance defines the a kind of a standard deviation in the data. Take two basic examples. One is the example of buying cement bags for construction of a building. If one bag has lesser amount and other has more amount, the variability doesn't matter, but the average value matters a lot. But in case of buying an expensive item like mobile set, like car, the average mileage is not important because average may be good, but you might have an hard luck. So if you have an hard luck, you might be on the lower side and your mileage will be very low. So in that case, the variability has to be controlled. So these are two parameters which are important in statistics. One mean and the other is variance. Now in this lecture, we will learn how to calculate the expected value of the mean and how to calculate the expected value of the variance from a given distribution. Distribution may be discrete in nature, distribution may be continuous in nature. That is already explained to you. So expected mean is nothing but the common among statistics to refer this mean as the mathematical expectation or the expected value of the random variable. It is generally denoted by Ex or mu x. In statistics, most of the things are based on source or a sample taken out of the source. In most of the times, we have a sample in our observations. We don't have an idea about the source. So sample may give you n number of values, x1, x2 up to xn, and the average may be called as x bar, and the variance among the sample may be referred as s square. But when we talk about source, the mean of the source is referred as mu, and the variance of the source is generally referred as sigma square. Here, when the distribution is given, we want to calculate the expected mean. This is the formula, discrete probability distribution, where you have to take a weighted average over the domain of x. X has a domain range R, which may be discrete in nature, 0, 1, 2, 3, and so on up to n values. Or it may be a continuous x having a domain where the values may be from minus infinity to infinity, anything in between values may be. But this fx is nothing but the probability of occurrence for the domain of x or the range of x. So in case of discrete, we have to take a weighted average. In case of continuous random variable, we have to integrate the multiplication of the weight of the value of the random variable as well as the respective probability. First example over here, take this. Suppose that the number of cars X that pass through a car wash between 4 p.m. to 5 p.m. on any sunny Friday has the following probability distribution. Then the expectancy of getting 4 cars. What is expected? Expected value for getting 4 cars between these two timings is 1 by 12. The probability of occurrence is, so contribution of getting 4 cars is in the average, in the expected value will be 4 multiplied by 1 by 12. So now if I say what is an average or expected value of number of cars occurring in that particular period will be nothing but summation x equal to 4 to 9, because there are these 6 possibilities x fx. Now what will be the expected value of expected number of cars will be 4 multiplied by 1 by 12 plus 5 multiplied by 1 by 12, having the same probability of occurrence, 6 multiplied by 1 by 6. Taking all this, going down, we can have 12 as a common LCM, 4 plus 5 plus 18. So sum of all this will be, so 82 by 12, this will be 41 by 6, so 6.8. So the expected number of cars may be about 7 cars this service station may expect on an average. So this is represented as the approximate mean of the distribution. But in this problem, what they are asking for is, let gx as 2x minus 1 representing the amount of money in dollars paid to the attendant by the manager. Find the attendant's expected earning for this particular time period. So the expected earning of the attendant is gx, that is calculated through 2x minus 1. Just change the color. So expectancy of x will be same as expectancy of 2x minus 1, because this is also dependent on x. So the expected value of g is nothing but summation over x domain 2x minus 1 multiplied by fx. So whatever I get for x, let's see here how to calculate it. The probabilities are here. Only the random variable will be changed here, but the probability of expected occurrence may not change. So it is 2 multiplied by 4 minus 1, then 1 by 12 plus 2 into 9 minus 1 multiplied by 1 by 6. So this will be the expected earning for that duration by the attendant. That will be the value which we can calculate over here. We can have 12, 34. So that will be the expected earnings in dollars. What is that about? 4, 9, 13 and then 16, 6, 1, 4, 7, 10, 13, 3. Sorry, I'm making a mistake. Count again. 4, 9, 13, 3, 16, 16, 9, 25, 25, 8, 32, 33. So 3, 6, 9, 12, 350 by 12. So that will be 12 whole number, then 7 by $12. So this will be the expected earning by the attendant. Take the other example of continuous probability distribution. In this we see X as continuous random variable. If X is a continuous random variable, our expected value of X is nothing but integration over the domain from minus infinity to infinity x fx dx. When we apply over here, again they want to know the expectancy of 4x plus 3. So this expected value for g is nothing but integrating from minus infinity to 0, then 0 to minus 1, then minus 1 to 2, then 2 to infinity. Let's see here, gx fx dx. This term is 0. Let's change the color. This term is 0. We could have combined these two as well, from minus infinity to minus 1, because it was given over here. Now from this will occur here, but this term beyond 2 is 0 as per the condition given 0 elsewhere. Move further. What is left here for the expected value is here minus 1 to 2 gx fx dx. That will come here as function minus 1 to 2 4x plus 3 multiplication x square by 3 dx. So if we integrate this, we are going to have constants over here, 1 by 3, then this function will be 4, x cube will become x4 by 4 plus 3, x square will become x cube by 3 for the range minus 1 to 2. This 3 will be cancelled out, this 4 will be cancelled out. It will be left as 1 by 3. For term 2, it is 2 to the power 4 plus 2 to the power 3. So that will be equal to 22 by 3. That will be over here 7 whole number 1 by 3. So that is the expected value of the mean for gx of the given continuous density function. The other term we were talking about was variance of the random variable. So variance is nothing but the standard difference with respect to the mean value. So if suppose on the x line, if suppose on the domain of x, this is a particular mean or what you call expected mean. So there will be deviation of occurrence. X1 may be suppose here, x2 may be suppose there, x3, then x4, then x5, x6 and so on. So now this is what I can change this lighter color. So now there is some difference with respect to mean value. This is a difference. This is a difference. This one is the difference. Then difference of x6. So all these differences are ex minus xi or vice versa. So now if we sum all these differences, we are going to have possibly a negligible effect. To avoid this, we square this and sum them all. This is called as variability in the data. But the weighted average of variability will be called as variance of the random variable. In the formula, let's see here in the formula, see here expected variance of the distribution for discrete random variable, and this is the variance of the distribution having continuous random variable. Now here we have to integrate over the range with the same weightage of fx, and here you have to sum over the range of the x domain with the same weightage of fx, because these are the probabilities, what we call the weighted occurrence, and square root of this is called as standard deviation, which is generally referred by sigma. From the same examples, we will see how to calculate it. This is one of the simplified version of calculating variance, which is obtained from a derivation that is called as E x minus mu square is nothing but summation over x domain for x minus mu square fx. So they simplify it into this form by opening this term as x square plus mu square plus minus 2 mu x. So they obtain this formula. Sometimes we can use this, or we can use directly the same formula given over here. If we have to find out the variance for this distribution, then we know the expected value is 6.8. So from the expected value of 6.8, we can calculate sigma square as E x minus mu square, which is nothing but summation x is equal to 4 to 9. Then it is x minus 6.8 square, then fx. So the term will become like this: 4 minus 6.8 square into 1 by 12 minus 6.8 square into 1 by 6. So all this will give us a particular value, which will be called as expected variance of the given discrete probability distribution. And the square root of this value will be standard deviation. In case of continuous probability distribution, if we have to find out the deviation, we can integrate the same thing over the range. So it will be here sigma square E x minus mu square is nothing but integration minus 1 to 2, then x minus 22 by 3 square, then fx is x square by 2, let's see, x square by 3, then dx. So if we integrate this over the range, we can get the values of the expected values of variance for a given continuous probability distribution. The square root of this will be the square root of this value will be called standard deviation expected. Because I want you to solve the problems yourself, and these examples will help you to find out the expected value of mean and expected value of variance for any discrete probability distribution as well as for the continuous probability distribution. Now, in the next part of this lecture, we will apply this concept for joint probability distribution, where more than one or rather two random variables have the occurrence for the same situation. Okay, bye bye for now.